a quick sketch here. This is this IC here, but only the left side. So these are the pins of the chip here. I didn't start with 1. I started directly on 8, representing the pin that is going to segment 0, which I already linked it here. Now we can look on these numbers that are mentioned here on the board. They actually represent the actual pin number of this chip, at least on this side. Is not true on this other side because it's wrong, but here on this side is absolutely correct, the numbering that is specified on this board. And I have 1, 2, 3, 4, exactly like here, if you can even see the numbers, 5, 6, 7, 8. So this is the 8, which is this one, segment 0. So I leave this as a reference. I already link it to the LCD. So next, these are the setting pins. I also include the power pins because in this particular case, you need 2 types of voltages, 3 volts for the LCD to power the actual LCDs, and 5 volts to power the chip, and a single ground pin, which is common with the 2 voltages. So you need only 3 wires pretty much for the power. And then chip select, write and data pins. So this is what I'm thinking. I'm not completely sure what to do at this point. I really don't know what to do. But I'm thinking to make new pads like this, relatively small pads, and link these 3 wires, and also with the text, write data. These pads like this will be connected to these pins, which means more specifically to this little vias that I'm having on this board with a thin wire, and somewhere there I can place it very close to the pins. So if I'm putting something here already, I will obstruct making holes from this side to this side. So I'm a bit in balance. I don't know what to do at this point, but it's a good idea to actually to protect these pins. After that, I will have to make, like I'm making this, another board, little board like this, but for the power, exactly like here. Also 3 pads like that, and also the representation, what it means. So this will be this will be 3 volts, and this will be 5 volts. So this is a little bit more complicated maybe. So if this is the entire board, what I'm having here, I will draw it like this. And here is this square in the middle, this board here with the chip. I will probably have to put a positive and a negative pads here and there, not to short them very easily, to be very, like here and here, and drag some wires. This will be the plus 5 volts, and this will be ground, 0 volts. And from these 5 volts, I'll have to use, exactly like I did it on the breadboard, I'll have to use a voltage regulator to lower the voltage to this, to this 3 volts here. Specific 3 volts for LCD voltage pin. I will have to make room for another board, circuit board, voltage regulator circuit. This little square, I will have to place it somewhere as well. I will have to make some room for it. Most probably here in the corner, I'm thinking right now. I didn't plan anything. Right now I'm just planning ahead. I'm thinking ahead out loud. This is my process of doing things like steps. Pack. I'm solving the problems step by step. Because I'm doing it directly in reality without any simulation where I can cut and paste stuff and delete and then paste it again in other position. If I'm making mistakes, I will have to live with them. Well, pretty much like I did last time. I did quite a big mistake, but I learned a ton from that mistake. I learned how to make it better, pretty much, and this is better, way more better than before, and I'm pretty proud of it as it is looking right now. But this is another challenge on top of everything else, and this 5 volts pad will also feed the microcontroller. So this will go here, it's 5 volts to the voltage regulator circuit that will deliver specific these 3 volts. So this is 5 volts for the voltage regulator, 5 volts for the chip, 5 volts for the microcontroller there, and 3 volts for this other pin, and also the ground wire, also for the microcontroller and for this chip. I will have to keep in mind that I'm having this last component that I will have to power. The problem is that I will have to think very hard and very serious where the hell I should place the positive and negative rails, and also this new circuit. It will be composed from exclusively with SMD components. I will actually use IMS 1117 voltage regulator, and it is a variable voltage regulator. Probably they should be actually a rail like this long, or some wires or some pieces of sheet metal like that, probably to benefit, to be extremely easy to access them from anywhere else, from this side, wherever I need to access them, to not to be a tiny little point there and then to drag a very long wire. That's my idea. How I will actually implement it, I will think about it, but that's the philosophy, and that's what I want. And that's a little bit of problem in itself, and I will have to think about it very hard right now, how I will do it. I have very restricted places where I can mount it, or even here I can mount it, because here is a very empty space, even if it's elevated like that, or here in the bottom. Yeah, it's a bit complicated. The wiring is the most complicated thing, but do not be afraid, because you are with me, and you will get courage I will encourage you to do it better, even if it's complicated. It doesn't matter. What it matters is to be happy in the end, to get what you want. That's all that matters. That's my philosophy, how I'm thinking. Okay, so here is my my box with smaller boxes, and I want this one, IMS 117. So maximum he can receive is 15 volts. The minimum he can output is from 1 volt. Actually, I believe is 1.2 to 5 volts. Well, you can output whatever here. A little bit less than 15 volts. 100 pieces, very cheap component, and I barely use them. I tested them here. This is a tested component. This is another tested one. So this is my voltage regulator here. Let's see, 1 kilo, and I do not have 1.4, but I have 1.3 there. This is 1 kilo here, and let's see, maybe I have some scrap 1.4. 1.5 is that. Let me look very closely to it, into it. Yeah, 1.5, which is exactly what I used on my breadboard, 1.5. I bought, actually, originally I bought this value 100 pieces, 1.3, and they are brand new, but later I added some scrapped components, so they are mingled there. Yeah, it is exactly 1.5. Yeah, it's good enough, because this is exactly on my breadboard, and it worked absolutely fine in all my tests, actually. So this is the new circuit that I have to build with the voltage regulator. These two components here, 1 kilo and 1.4, and then two capacitors, 470 microfarads and 1 microfarad, and probably this diode here, 300. These are interference capacitors used to cut interferences from the power supply. They are smoothing capacitors pretty much, and yeah, the bigger the better. But you can put also smaller as well, 100 microfarads. You can put that as well. It will smooth, not as well, but good enough. You know, it will be fine. I didn't even put on my breadboard. I didn't put this input capacitor at all. I only put this output capacitor, this 1 microfarad. Usually they are pretty small in size. So here, 1 micro. 1 micro. Also this diode, which is not absolutely necessary, but is a good protection diode. This is only for protection. If you are making a short here in the input, this diode will protect the output or whatever is there that is receiving the shock. So actually, I will use something that is already used. This is a used diode, but it's very big. That's one model of a diode, which is a very good diode actually. It's a Schottky diode, and is this model. Here it is also mentioned here, Schottky diode. But I have another model here, this 4148 equivalent, but in SMD form. And I have quite a bunch of them. This is the SMD version, is 1206. You can see it here mentioned, 1206 package, and it's very small. I should probably use this. I'm thinking. I was actually imagining everything a little bit more smaller than this. These two capacitors and also this diode are adding a lot of space. They are eating a lot of space. But let's see if I'm smart about it. I believe I can put it somewhere here on the top and long like that. The problem is that this 3 volts line or wire will have to come back and link here on this pin. And I have no idea how to proceed from this point. Or to build it here on the top. And this will facilitate, I will not have to drag that many wires. I will have to add a very small wire from the 5 volts rail to the voltage regulator, and then 3 volts here, and that's it. But I'm having a lot of power wires on this side where this LED will sit on the other side, and I will have to deal with that later. This is the name of the game. I will deal with it later. It's a universal rule, you know. Deal with it later, not now. Right now, something else. Yeah, I'm very inclined to mount this voltage regulated board here, not there. Not here, but here, very close to here, because it's very convenient, very convenient. 5 volts there, 0 volts from this other side, then 3 volts there, under 5 volts as well here. So it will be a very good choice, a very good design to have it here. The problem is that everything will get very condensed and concentrated here, very concentrated. But it's a very good location there. I'm happy I'm having this space now. Oh, I will have to add some paper with glue on top of this and also here to protect the wires and also to look nice. But I'm an idiot and I will leave it for later. Now I will concentrate on this problem. The voltage regulator circuit will be somewhere here, and this pad there. And then this pad, I don't have space for this to add it here. So I'll have to add, to drag bigger, longer wires. Probably, you know what? I can drag them like that there and make this little board here, and then drag from here to the chip. What a mess. There on top or here on the bottom. And I don't know at this point where the pins, these 3 pins should go on the microcontroller. I'm not completely sure where to add them. Positive, negative. I'm trying to imagine how everything will fit. Very, very shitty. Very shitty. So 9 is here. 10 is not used. 11 and 12. So this 3 pins here, or this square, is the data. And 13 is ground. 14, 16 is. So this, and 17, this. Yeah, like a V. This 3 will be the power. Huh. Plus the pads and the wiring. I believe it's good enough, this size. I can fit everything. And I can even add those bigger capacitors and bigger diode, probably. Because I have quite a good amount of room here. Of course, this is just placing and visualizing. Okay, I'm thinking right now to add those bigger capacitors. Here I can add this bigger capacitor somewhere here, because I have a little bit of room, of space, especially here in the bottom. So I need 1, 2, 3, 4, 5 pads, and that's it. Maybe another one, a little one here. I'm also thinking on adding a power LED. It's always good to have a power LED on any circuit that you are making. So this is a 10 kilo or 1 kilo, whatever you have to fit in. It's good. It's always good to have it, but I have no idea where to mount it. And let's actually fit it here. All right. Pretty small 3 volts power supply, cardboard, correct? So this is a cardboard, very easy to make, and let's do it. I will stop with the rail until here, and then I will jump a wire to this other part. Okay, let me actually check with those big capacitors. This, but one of these, because I have more 300. So this one here. All right, and 1 microfarad, and it was this, which is here. Perfect. This is perfect. So I will have to modify here a little bit, but this will fit quite good. Okay, now I'm happy. Now I'm happy that because I'm getting rid of bigger capacitors. These are scrap capacitors. These are not new, and they are questionable how good they are, but they will do their job. That's why it's good to erase now than to cry later. And also, let me add 3 pads. These 3 pads. I will shoot 2 rabbits with 1 fire. So this is good idea. So I will make it a little bit longer than this. I already cut this, but it's very close, very close to what I'm having here. Very close. It's almost perfect, exact. Huh. I have to write this. So my new board will be this height, this new height until here, because I have to write what these things means. Damn it. I can put this writing. I was thinking to add it between these pads. This means to put this pad a little bit here on the sides. Yeah, a little bit fucked up, but I believe it will work. Interesting, no? And yeah, I believe this will fit that. Okay, good, better. Now this is better. And this dial here, but I believe I can put a larger one. Yeah, definitely it can work there. All right. Okay, all right, I like it. Okay, it looks like it's good enough. So this is my voltage regulator. So everything it is fitting there perfectly. So I just made a double check right now. What I'm thinking right now is the following: to add all these pads, after all, drag the wires to their pins there underneath, and over it I should put a cardboard, and on that cardboard this module with these 3 data pins. So the wires from here will go like this until they're underneath this cardboard, and also the 0 volts wire will go underneath this pad here, so it will be stick there and connected there. And this 5 volts from here, I can actually drag it underneath as well. So this means all these pads, they must be shifted a little bit to leave a little room there. So this is the wiring that are intersecting each other. I can make a very nasty short circuit here between the 3 volts and 0 volts, 3 volts and ground, and between 5 volts and 3 volts or the ground. I will have to add very serious protection. All right, so I come to a conclusion, and the conclusion is I will make here in this space, I will put these data pads connected to these points. pin 9, 11 and 12 will jump directly to these pads here. Why? If it's here, I will have to drag them this way and then drag them that way to the microcontroller, because these data wires are they are commanded directly from the microcontroller. So this way, putting them here is a little bit turned, but in the same direction, is not go forward then backward. So you see my point? This is very important to have them in the same direction. So that was clear enough for me. It was a very good idea. Then I'm having here the problem of voltages that are literally overlap each one on each other. It's an intersection of everything. 5 volts intersected with the ground, 5 volts intersected with 3 volts, 3 volts intersected with the ground. So everybody is intersected with everybody. I have multiple points of intersection actually, which is very, very extremely bad. So my solution is to build multiple layers of protection from cardboard. So I will drag first, doesn't matter which value I will add. If I will drag first the 0 volts here, I will put a protection layer, a cardboard, I will glue it here. Then on top of it, I will link this 3 volts to its corresponding pin, another cardboard of protection, and then finally the last wire, 5 volts, to its designated pin, and most probably another layer of protection, idiot proof, like that. And what I will have in the end, I will have a block of cardboards with 3 wires coming out of it, and then 3 wires that are going into the connections, and that's it. This will be a very glued block that will be always there. It will not be, I cannot take it out and put it elsewhere. So it will be a constant element there. And that's my solution. This is my solution. This is the best idea I could come with. Here, if these wires will intersect, these data wires, is really not big of a problem, because they are separated from the voltage wires. The voltage wires will come here in this direction like that, and the data wires will go in that direction. So there is no chance of intersecting these data wires with the power wires. So this is it. This is the entire thing, making happy everything. This is a very good balance of everything what I'm having here. So this was quite an important detail, the power wires and the data wires. This was quite quite something to deal with, especially to deal with these pins what I'm having here. Right now we can start and build it. I know they are very sick, a little bit more sick than usual. And I have to chop them. These are legs from very old components, very sick, very good actually. I believe they were some resistors, Russian-made resistors with very thick and wide legs, and I had to cut some of them off, and I'm repurposing them. All right. The problem is they are a bit too thick, but and it's hard to bend them safely, not to damage the cardboard. That's the problem. But this is not first time when I'm using them. Good enough, although it is standing outside a little bit, but it's not that big of a problem. All right. Yep, it's good. Now I can press it a little bit. This is a little bit out of normality here. Yeah, it's good enough. Now it's a bit more flat than before. And next, these things. Yeah, no, it's a little bit of liquid. Excellent, excellent. All right, this is it. All the pads are mounted, and now the components. Holy shit. Huh. My voltage regulator cracked. Ah, fucking hell. I probably pressed on it too hard or something. Ow. Or it was too hot. But I destroyed it. Ah, fucking hell. Look. Its pin fall off from here. Huh. Weird. This is the first time it's happening. Ah, another one. Another one. I have plenty of them, but not nice to get damage like that. It might be because of thermal contraction or something like that, thermal stress, or I just press on it too hard. I might have pressed on it too hard. Yeah, and it was also hot. So I will not press super hard on it then. All right. All right. All right, and now the diode. Okay. Yep, it's good. So I need a link from there to there. So from here to here a link. Ah, motherfucker. Pizda mati. Okay. Let's say that this is good enough. A wire from that to there, so from here to here. This looks like a perfect candidate. All right. Let's add some isolation, specific isolation for this wire. Excellent. Voila. I was planning to put this wire underneath, but this is more straightforward and direct. Okay. Now to test it. To 5 volts, exactly 5 volts there. Volts here. Perfect. Perfect. Do you see it? Perfect. How cool is this, huh? Very good, very, very good. Excellent. Works like a charm. Oh, this was something. This was something. So this, I can put it aside. I don't need it anymore. It looks like these pins are going there, there, and there, but from this angle here, this board is lower than those pins, so those pins are not touching anything. It appears to touch something, but they are not. So it's good enough. I can glue this board now, like that. There. Holy fucking shit. This was hard. This was hard. But it was nice. It was also nice to make it. And it will be extra mega nice when it will actually work. I hope. And I hope I will not have any problems. Especially now in testing. The first thing I will do, I'll do some testings. I really don't like these pins here, 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 and here. Let me try to correct them. I hope I will not fuck up. Okay. I worked literally all day on it, and it was hard. I have how many days? 2 or 3 days of working continuously on it. Holy shit, this was hard, but it came out very beautiful, actually. I put a little bit of glue on the wires, and I hope that glue will do its job and actually stick the wire to the board. But I didn't put the glue between the board and the wire. I put the glue on the wire. I hope it will adhere to the wire and to the surface adjacent near the wire. Ideally is to add the glue before and then put the wire on the glue and let it solidify. This was very important job, to do it as cleanly as possible and not to make shorts between this point and this point, and this is actually going around like that. I put a little bit of spacer here, which is good as well here. In my book is good enough. So theoretically, right now, done with the LCDs and with the LCD driver, and I can power it, this module, this entire module containing LCDs and LCD driver and voltage regulator. I can power it, and theoretically, I hope I didn't forget anything. I can put some wires here to the breadboard, and I can actually test with my Arduino device that I'm having there, and actually test this entire thing powered by itself with its own LCDs, with its own LCD driver, and also in the same time verify if everything is linked correctly. And if it's not, if I made a stupid mistake, I'm totally screwed, which is not impossible, but because it was 1 million links to add, and it's a very big probability I made somewhere a mistake. I really hope not, because I was careful. I checked 3 times for everything, for every wire. I was very sure I was connecting everything correctly, but you know, shit happens even to me, to everybody. We will have to test it and see it, how it plays out. If it plays out okay, whew, I am gold. If not, I am shit. All right, I hope you like it. Also leave a like, don't forget, don't be a bastard. Fucking hell, hard, super hard, but in the same time very fun, very fun to make it. All right.